Welcome to Question with Answer. Today, we're diving into the top 10 interview questions on generative AI that are trending in 2025. Whether you're preparing for a job in AI, machine learning, or data science, this video will help you stand out. If you're ready, let's begin. Question 1. What is generative AI, and how is it different from traditional AI? Answer. Generative AI is a subset of artificial intelligence focused on creating new content such as text, images, audio, or video. Unlike traditional AI, which primarily focuses on classification, prediction, or decision-making, generative AI generates novel data that resembles the training data. For instance, a traditional AI model may identify objects in an image, whereas a generative model like GAN or a transformer can create a completely new image from scratch. The key technologies behind generative AI include variational autoencoders or VAEs, generative adversarial networks or GANs, and transformer-based architectures like GPT. The ability to mimic human creativity is what makes generative AI unique. It powers applications like ChatGPT, DALL-E, Midjourney, and voice synthesizers. These models are typically trained on vast datasets and use deep learning techniques to learn the statistical structure of data, enabling them to produce high-quality synthetic content. Question 2. What are the most commonly used models in generative AI? Answer. Generative AI models come in several types, with the most popular being generative adversarial networks or GANs, variational autoencoders or VAEs, and transformers. GANs consist of a generator and a discriminator competing in a zero-sum game. GANs are especially powerful in generating images, art, and photorealistic visuals. VAEs learn to encode data into a compressed representation and decode it back with slight variations, making them suitable for image reconstruction and denoising. Transformers, like GPT-4 and BERT-based models, are widely used for text generation, summarization, translation, and code generation. Among these, transformer-based models have gained enormous popularity due to their scalability, parallelism, and high-quality output. For example, OpenAI's GPT models, Google's Gemini, Meta's Llama, and Anthropic's Claude are state-of-the-art transformer models. Each model has unique strengths and is selected based on the use case, whether it's generating realistic images or writing coherent long-form text. Question 3. How does a transformer model work in the context of generative AI? Answer. Transformer models are the backbone of modern generative AI, especially for natural language processing tasks. A transformer consists of an encoder-decoder architecture, though models like GPT use only the decoder part. The core innovation is the self-attention mechanism, which allows the model to weigh the importance of different words in a sequence regardless of their position. This enables it to understand context better than traditional RNNs or LSTMs. In generative AI, transformers are trained on large corpora of text and learn statistical patterns of language. During generation, the model predicts the next token, word or subword, in a sequence based on the previous context, making it ideal for tasks like content creation, summarization, translation, and code writing. Transformers scale well with data and compute, allowing models like GPT-4 and beyond to reach human-level fluency and coherence. Positional encodings are used to maintain word order, which is crucial in generating syntactically and semantically correct outputs. Question 4. What are the limitations or challenges of generative AI? Answer. Despite its impressive capabilities, generative AI has several limitations. Firstly, bias and fairness are significant concerns. Since models are trained on large datasets from the internet, they often inherit societal biases, potentially producing offensive or harmful content. Secondly, hallucination is a major issue. Models can generate confident but factually incorrect responses. This is especially problematic in applications like healthcare, legal tech, or education. Third, data privacy and security risks arise if models inadvertently leak sensitive or copyrighted information from their training data. Generative AI also requires enormous computational resources to train and fine-tune, making it inaccessible for small companies or developers. Lastly, there's the ethical concern about misuse. Deepfakes, spam content, and misinformation are becoming easier to generate. Addressing these challenges involves improving data curation, using human-in-the-loop training methods like reinforcement learning from human feedback or RLHF, and deploying AI responsibly with content filters and safety layers. Question 5. What is reinforcement learning from human feedback or RLHF? Answer. Reinforcement learning from human feedback or RLHF is a technique used to fine-tune generative AI models, especially large language models like GPT. After a model is pre-trained on vast datasets, it may generate content that is syntactically correct but not always aligned with human expectations or ethical standards. RLHF bridges this gap by introducing human preferences into the training loop. Here's how it works. 1. A base model generates multiple responses to a prompt. 2. Human annotators rank these responses based on quality. 3. These rankings train a reward model, which assigns scores to outputs. 4. Finally, reinforcement learning, like proximal policy optimization, uses this reward model to fine-tune the original language model. RLHF helps in aligning AI outputs with human values, improving relevance, reducing toxicity, and making the responses more helpful and less biased. It's a crucial step in making models safer, more controllable, and more suitable for real-world deployment, especially in consumer-facing applications. Question 6. How is generative AI used in real-world applications? Answer. Generative AI is revolutionizing multiple industries by automating creativity and content generation. In marketing, it's used for ad copy, email campaigns, and personalized messaging. In entertainment, it powers tools that generate music, write scripts, or create realistic virtual environments. Platforms like DALL-E or Midjourney enable artists to create images from text prompts. In healthcare, it's applied for synthesizing medical images, generating patient summaries, or even drug discovery through molecular generation. In finance, generative AI assists in scenario simulation, synthetic data creation, and personalized financial advice. Gaming studios use it to create character dialogue, storylines, and even voiceovers. In education, it's used to generate custom study material, quizzes, and learning paths. Additionally, software development is seeing a surge in tools like GitHub Copilot and Amazon Code Whisperer, which generate code snippets, autocomplete functions, and even write unit tests. The versatility of generative AI is driving innovation and increasing productivity across domains. Question 7. What are diffusion models and how do they differ from GANs? Answer. Diffusion models are a newer class of generative models gaining popularity for their ability to produce high-quality, realistic images. The core idea involves modeling the data generation process as the reverse of a diffusion process, starting from pure noise and gradually removing noise to form a structured image. During training, these models learn how to add noise to images over time. During generation, they reverse this process step by step, denoising a sample until a coherent image emerges. Unlike GANs, which can be unstable during training due to the adversarial setup, diffusion models tend to be more stable and consistent. They also allow more controlled generation, like modifying specific parts of an image. Models like Stable Diffusion and Imagen from Google have shown remarkable results with fewer artifacts compared to GANs. The trade-off is that diffusion models are computationally more expensive during inference due to their iterative denoising steps. However, their output quality and flexibility are making them a popular choice for next-gen image generation. Question 8. What is prompt engineering and why is it important in generative AI? Answer. Prompt engineering is the art and science of crafting effective input prompts to guide generative AI models, especially large language models, toward producing the desired output. Because these models are highly sensitive to input wording, even slight changes in phrasing can lead to significantly different results. In prompt engineering, users experiment with input structure, specificity, examples, few-shot, or constraints to influence the model's behavior. For instance, a prompt like, "Write a professional email declining a job offer," will yield a different tone than, "Say no to a job nicely." Prompt engineering is crucial because it allows non-programmers to control AI without retraining the model. It is especially important in use cases like chatbots, summarization, code generation, or creative writing. Advanced techniques like chain-of-thought prompting, zero-shot, few-shot, or role-based prompting, for example, act as a lawyer, help extract better quality responses. As models evolve, prompt engineering is becoming a valuable skill in deploying and managing AI tools effectively. Question 9. How do fine-tuning and instruction tuning differ in generative AI? Answer. Fine-tuning and instruction tuning are both techniques used to adapt pre-trained generative AI models for specific tasks, but they serve different purposes and follow different approaches. Fine-tuning involves retraining a model on a labeled dataset to specialize it for a specific domain or application. It modifies the weights of the model, which allows it to learn domain-specific vocabulary or behavior, such as legal or medical language generation. Instruction tuning, on the other hand, trains the model to follow natural language instructions better. This is done using datasets where inputs are structured as instructions and outputs are expected responses. It doesn't necessarily narrow the model's knowledge but makes it more adaptable and controllable. For example, the difference is like training a chef to only cook Italian food, fine-tuning, versus teaching them to follow any recipe more accurately, instruction tuning. Modern models like FLAN, T5 or OpenAI's ChatGPT use instruction tuning to follow user prompts more effectively, making them more versatile across tasks. Question 10. What are the ethical considerations in using generative AI? Answer. Ethical considerations in generative AI are critical due to its ability to produce realistic and potentially misleading content. Key concerns include: 1. Misinformation and deepfakes. Generative AI can be misused to create fake news, videos, or audio impersonations, threatening public trust and security. 2. Bias and discrimination. Models often reflect the biases present in their training data, which can result in offensive or unfair outputs. 3. Data privacy. If training data contains personal or proprietary information, the model might unintentionally reveal it during generation. 4. Copyright and ownership. Content generated by AI may mimic or reuse patterns from copyrighted works, raising legal questions about authorship and intellectual property. 5. Job displacement. Automation of creative tasks may impact employment in content writing, art, and programming. To mitigate these, organizations must enforce responsible AI practices, such as human-in-the-loop systems, transparency reports, watermarking generated content, and adherence to ethical AI frameworks. Governments and companies are actively developing guidelines to ensure generative models are deployed safely, transparently, and fairly. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.